Compilers are the translator between the code you write in C or C++ and the machine language, the ones and zeros that your CPU or GPU can actually understand and execute on. My name is Adi, I'm a software engineer at Amazon, and in this video I'm going to explain how do compilers actually work. So compilers basically go through a 5-step process before they can execute your code or turn your code into something that is executable. That's actually what the file is called once they do compile. It's called an executable. You just run that file, it works perfectly. And compile languages, or like C or C++, are extremely fast because they translate everything at once, whereas the alternative, which is interpreters or just-in-time interpreters, are far slower, sometimes 10 to 100 times slower. And so compilers start with the lexer or lexical analysis, where they check every single word or variable and they identify what it is exactly. It's like you going through an essay and every word you're identifying it as a noun, adverb, verb, adjective. Instead, you go through your code base and you go, this is a variable, this is an operand, this is an if, like clause or whatever you want to call it. Next, you have syntax analysis, which looks at the whole sentence of that essay and make sure grammar makes sense. Or in our case, we're going to be going through and saying, okay, this is an if statement that is checking for this check. Or this is a for loop that's going to iterate 4 times or 5 times. This creates something called an abstract syntax tree of basically like what will need to come first, then second, how will everything interconnect? Maybe you're calling a function in another function, like, okay, we have to first parse out function A that is needed in function B, like all your dependencies. Then you do semantic analysis that makes a deeper understanding of your code base and make sure that all the code you write actually follows the rules that were set by your programming language. So it like actually follows the rules of C or C++ and those like syntax rules. Next, you have optimization. So all your code has been written in C or C++, but it's going to be then translated into the instruction set that your CPU can understand from to like assembly code. So it's going to be either CISC, which is complete instruction set, like code essentially. I forgot the exact acronym name, or RISC, which is for like ARM processors. It's going to be different from M chips, which are Apple's chips, or ARM chips, which are your phone's chips, or Intel x86 processor chips, which are used in a lot of Windows laptops. And then it's going to optimize that. So it's actually going to clean out some code. It's going to make it faster. So that's why it's optimized. And so like compilers like for Rust take a longer time to compile because they're optimizing for a greater deal of time, whereas C or C++ optimize less. And the longer you wait to compile, the more you're optimized. And then it'll generate that code into the ones and zeros by translating. And that's all there is to a compiler.